Hey everybody, Laz here. Alright, so I'm seeing issues in route summarization. Route summarization, it's right there. It's the purpose of route summarization is to reduce the amount of route entries, alright, or the networks that it's coming into your router on coordinate routers for the routing table. So you have core routers in your particular network, all right, or intranet routers, because right now the global internet routing tables are over 1 million routes in the routing table, and that's due to improper aggregation, as they call it, all right, because we are using BGP out there in the routing table. And so they're saying that it's improper aggregation, improper summarization that's causing all these issues. It could could be true, but how about just switching over to IPv6 and we should be good? But that's another lecture. So definitely we need to know how to summarize. Even though in one book for the CCNA, I forget who the author was, said that summarization it's not needed anymore. Okay, yes it is. That's why we created the Lisp in the SD-WAN category. Anyway, if you summarize correctly, if you summarize your networks and you're sending out summary addresses to these core and internet routers, that will make path selection more efficient. Why is that? Because these core routers and these internet routers, their routing tables will have a summary of that network address. It will make a quicker decision on which way it should send you, because all those other networks are encompassed in one address, because the smaller the prefix length of a network address, the more IP addresses you'll have more IP addresses in that one network address. I mean, that's just, that's just basic IPv4, since apparently this is the main issue, IPv4 addressing. So what we're going to do here is we're going to calculate, and this just really just very simple, two simple examples, but the concept is what you need to understand. By doing it this way, you are not going to run into any issues. Your router iOS is very intuitive, at least for some routers, and it's going to let you know at the binary level if you put a wrong subnet mask when you're summarizing, because that's the key, finding the correct subnet mask, that you're going to, it's wrong. No, binary bits don't follow through, so it's wrong. All right, so here we have a class B address. Let me bring this down here. A class B address. All right, all these are class B addresses, which I took the third octet, and this is why I labeled this so you know where I'm working at right here, because this would be the interesting octet, because that's where the numbers change. So this is the third octet. So I put it already in its binary bit values. I'm not going to bore you to death turning a decimal into binary. All right. So I take that third octet because that's the interesting octet. That's the octet that I want to summarize. All right. And that's where I'm going to be doing all my work, and put it into binary. Now the rules of summarization state that you should have, and you should start with an even number network, which we do. It's even. Well, it's not even really, it's odd. Sorry, looking at the wrong octet. It's odd, that's an odd number, so we're violating that. You should have an even number of networks, which we don't. We have an odd number of networks. And, what's the last one? You should have an odd number of networks, we don't. We should start with an even number of networks. And, oh yes, and we are following that it is contiguous. Right, it is contiguous. 1, 2, 3, 4, 5, right? It is in order. So we're only following one out of three rules. So when I turn this into binary, what I'm going to do is I'm going to look this way, because the original mask, just so you know, it's a 24. If you didn't guess it by now, it's a 24-bit mask. That's the original mask. So what I'm going to do is I'm going to look from left to right, and I say, okay, all these in these columns, right? These bit value columns. I'm going to look if there's any uncommon bit values. If they're all zeros, I don't mess with it. If they're all ones, I don't mess with it. So we got all zeros all the way to reach to this column. when we get to this column, we have zeros and ones. So there is where I draw my new line. So I'm going to come down here, draw my new line. So that will be my new subnet mask. So how would that be? How did you know? I said 1, 2, 3, 4, 5, 6. So these two don't change. So that's 16, right? You got 8 bits here, 8 bits here. That's 16. 17, 18, 19, 20, 21, 22. And so our new mask would be 22. And I'll count that again for those of you that missed it. You have 8 bits on here. You have 8 bits on there. We're working here, so that's 8 and 8, 16, 17, 18, 19, 20, 21, 22. That's it. That is your new mask. Okay, so what is the address, the summary address that we're going to advertise? Well, it's going to be 172.16. That doesn't change. And then what do you see on? There's no binary bit that is on in this section right here in the third octet. So therefore, this is 0. And are we doing anything in the fourth octet? No, we're not. So that's 0. So what's the summary address? 20. What's the mask? 22. So this is the summary address. And I'll put it in dotted decimal since that was in CIDR notation. 255.255.252. Oops. 252.0. This is the summary address that you would advertise that would encompass these 3 networks and then some. Because already you see that you have the 0 network that comes into play. So you got to be careful when you're summarizing, because if you don't follow the rules, even if you do, depending on the number that you're using, because you can have even number networks and you can have them sneak in other networks. Okay, but we'll talk about that in a little bit. So this is your summary address, but we never had the 0 network before. There was no 0 network here. But it is now. All right. So, but this would be the summary address. This would be the summary address. This is the concept. Let's do the next one. All right. Let's bring this up here. So now we're focused over here. Okay. This is the summary address up here. So again, let's just copy paste this. So save some time. And we want the new mask, obviously. All right. Which we don't know what it is yet. Now, some people say, well, we could just do 192.168.0.0. Sure, you could. You could do that. And your books in the CCNP do that. But is that correct? You're just adding a bunch of other networks that you don't really have. So that causes a security issue, doesn't it? Okay, or you're just being lazy. You don't want to, hey, we added another network. Oh, wow, we got to change the summary address. So, you know, that's what you do, but then face the consequences. Hey, we got hacked. Well, we're going to tell you. All right, so we have a 24-bit mask. It's a default Class C. This is a Class C regardless. Again, our focus is the third octet. That's why we're here. All right, again, this concept that we're doing, you can apply it to whatever octet you want. It's the same thing. Put them in binary, find the uncommon bit values, you're good to go. So like I said, so where do we see uncommon bit values in the third octet? Is in the, no, 128 is good, 64 is good, 32 is good, 16, 8, 4, and the 2 again. All right, let's draw a line, then I'll talk a little bit about something, about the rules. So here, we are following the rules. We start with an even number network. We have an even number of networks, and it's contiguous. So we're following all the rules for summarization. Perfect. So we got it in the same place. Okay. So we know that these two are not going to change. But what's the new mask, first of all? All right. So we had a 24. So it's the same thing, 22. Right? 8 and 8 is 16 plus 6 more bits is 22. So no math there. It's the same on top as the bottom, but we're using a different networking scheme, obviously. All right, so that's our new network. We know that the first two are not going to change. We already know that. And let's give it some space here so you can see it better. Okay. 192.168. And then now, what do we have here? What do we put in third octet? Well, up here, there was nothing on, so it was all 0. But here we have certain things on. We have 64 and 32 is 96. And 4 is 100. And they're on all the way down. All the way down. I drew my line where there was uncommon bit values. These are common bit values. They're all common to each other. So I have certain things on, though. I can't just ignore that, right? So this is 32 and 64 is 96 plus 4 is 100. So we're going to have 100, and then the fourth octet, well, it's just 0. And then what's our mask? We'll put it in dotted decimal, 255.255.255.252. And you get that as your answer. So this is the address that would encompass the 100. That's right here. And if you were to add these two bit values, which is 3 to 100, you would get 103. So you don't sneak in any other network. You don't leave out any network. So you have the exact number of networks. Now, some of you may be saying, Laz, but in a real world scenario, or in the real world of networking, we could do this if we wanted to. We can say IP, summary, address. I may have missed a hyphen, I don't know. Summary address, I tab a lot. We can just do 172.16.0.0, 255.255.0.0. And we're going to do the same thing for IP, summary, address. Is it one too many M's there? Yeah, it didn't line up. Speedy fingers. Oh, and I forgot something. Let's say we're doing EIGRP. EIGRP 100. And then you put the actual summary address. EIGRP 100. This is how you would do it in EIGRP. 192.168.0.0, 255.255.0.0. Now okay, you can do that. It'll work. It won't error out. But now you're advertising all 65,534 or 36 networks that would exist in there. And the same thing goes for the Class C. So is that an easy way out? Sure. You don't have to calculate. That's great. That's awesome. But when you go take a test, that's not reality. In a test, you better, don't worry about the rules in the test. Worry about how to do it. So learn this method, because you will never, ever go wrong unless you yourself make a mathematical mistake and change it into the bit value from decimal to binary bit. Other than that, is the easiest and quickest way to do it. But this, what you see here, this is just laziness and cheating. Pure and simple, unless you're on such a high, core internet router that has all these Class Bs in the 16, and you can say, well, hey, I want to go ahead and just, anything that has a 172.16, just send it this way. If that's what you want to do, okay. Anything that has a 192.168, just send it this way. I can see that if you're that big, so you don't have to keep summarizing, and you do have these networks, okay, but do you have 65,500? Do you have 65,000 plus networks in your building? Do you? That you're sending a summary address like you see down here? No. No, you don't. So this is the way you summarize. This is not the correct way, the proper way to summarize. All right, this is just pure laziness. All right, so the way you summarize is like this. All right, so when you're doing your certifications, when you're CCNA, whoever tells you in the CCNA, because I will never tell you this, that route summarization is something that is needed. All right, here you need to learn how to do it this way. You learn this method, you can take this wherever you want to go with whatever you want to do in IPv4, and you'll be just fine. Just fine. And especially for certification purposes, because they ask you to summarize networks, or hey, based on this network, what is the range and stuff like that. But for real world situations, if you do this, then you're asking for trouble. Down here, what's highlighted, you're asking for trouble. So summarization is something that is needed. So if anybody that's teaching you, that's not me, and they're telling you that summary address, route summarization is not needed, they have no idea what they're talking about. They're clueless. Because route summarization is important, and it's not the same. It's different per routing protocol, as it holds true, because I'm going to do for you, I see two labs, two separate labs. One is going to be an EIGRP lab, and one's going to be a BGP lab. one's going to be a BGP lab. And you can see there's different ways of summarizing or aggregation, as they call it. It is important. It is important because that's why they created, look at your CCNP Encore book, those of you that actually read it, that section begins the reason why they created Lisp. Because of the lack of aggregation. That's in one of the bullet points. That's one of them. The lack of aggregation or incorrect aggregation. So this is something that's needed because they created map servers, map resolvers, RLOCs, EIDs, all sorts of acronym happy terminology and technology, obviously, so we can go ahead and get information across the internet because our routing tables are over 1 million routes in the global routing table on the internet. So this is how you summarize. So make sure you practice this. Invent whatever networks you want in the 4th octet, 3rd octet, wherever octet you want. And practice this method. It's going to be the quickest and easiest method because you also got to, when you're reading your books, correct their errors to make sure everything is good to go. All right? All right, so after this, get ready for some labs. All right, it will be 2 separate labs, like I said. One in EHRP and one in BGP. They'll be completely separate, one from the other. I'll see you there.